digital transformations? It's all about in the multiple areas. There is something like economy depends upon on the technology. Okay, how the students and the faculties would be able to leverage the technology, and then they'd be able to deliver the technology, and then the new kids or the millennial kids, how they could be able to learn much faster on the technology. This is where the campus, the motivations, how they're going to deliver it, so that they'd be able to come back with lots of avenues for the learning various stuffs. If you look at a typical campus, there is various attributes. One would be how the classrooms, it used to be something like, we have one particular classroom where there is a set of 30 or 40 students who would be there, who go and then attend it. In a new generation, so things are happening, I don't want to go for a complete this particular stream. I may need to have something like I need to get 48 credits, maybe a 10 from the ECE, the 4 from the EEE, or some from the mechanical. I may want to learn the multiple areas. This is what some of the students are believing that's what required to handle the new challenges. In such cases, it would be very difficult in a conventional classroom situations. Think about situations where when a lecturer is delivering a training, okay, how about a student knows and then testing it, how this could be experimented immediately. Suppose a lecturer is explaining about how the new graphical designing can be implemented, okay, for the new challenges. Okay, all would be theoretical. There's two challenges here. One for the lecturers. While he coming to the class, he may need to experiment certain stuffs. So that he can say this could be better way. Now for the lecturers also who is having a class at 11 o'clock, he can't test it anything before the morning. He can't invest all the application, hardware and software at his home and then try it out. That's not possible. Or coming to the lab and then switching it on, not would be possible. Now you could have situations where you have everything is be digitally transformed, where it's been available all the time. I'll explain how this would be possible. Before a lecturer comes to the class, you would be testing it, how this is be working on it. Then he delivering the lecture. While he delivering itself, the students would be able to experience it, how he could be able to test it. That gives the learning experience a completely different format. It's no more something like a book form or theoretical methods. Point A, point B, point C, point D. It's not that. You'd be knowing it clearly how this could be done. Or the many other things, the other would be the libraries part of that. Let's say for example, there are many journals, things are available. It is very much possible for the campus to subscribe and getting it. The challenge would be how they could be able to distribute these to the students. Many things would be a soft copy. They can't give the PDF to everyone. Then it becomes a license violation. Then the particular vendor who is supplying it, they will not be able to supply it. They stop doing it. So rather than you doing it, you publish it in the common portal, where the students will be able to access the labs and then access the journals and various magazines whenever required from wherever they are. Probably the night 11 o'clock you want to understand what's the new, the ways of designing it. Sitting at home you can be able to access it. At the same time, a restriction would be there where you cannot download the particular files, download the particular journal and then distribute to somebody else. So they could be able to learn anything much faster. Or the labs. What are the new technologies are coming there, how soon you'll be able to learn it from wherever you want to go there. Typically, if you look at any particular labs in any institutions, would have something like an operational times. We have something like 24/7 is got per week. But a college would be operating from a Monday to Friday, maybe a Saturday, 6 days per week. And it would be operational, let's say 8 hours. Then only the 48 hours. Even if you take it 12 hours, okay, that again would become only the 60, it would be 72 hours where the lab would be operating it. But all the machines put it in the lab is been invested for the 24/7. Means it's not switched on for the many of the times. So the students who want to learn it, they have to necessarily be there at the lab only between 9 to 6. Maybe extended to 9 to 9. If at all, if in certain institutions, where you would be allotted a time of something like 1 hour per day. You may need to reserve it if you want to have more times. Or specific periodicals where you need to go there in the lab and then trying it out. This is for the conventional systems. In the new generation, it's all about using the digital transformations. You can be able to have a lab could be accessed by the student whenever they want it, from wherever they want it. Suppose at the night 12 o'clock, suddenly I just want to try it out a new particular design part of that. I just log into my particular campus website, just start doing it. Otherwise, to do that same thing, what you need to do it is, you need to invest on the high-end desktops or high-end laptops with all the expensive softwares. the software will become pretty expensive. The student may not be able to afford it. If at all, only few students would be able to afford it, not all the students. That's what the challenge is. This could be addressed. And these use cases, what we taken it. Of course, I have not included the BIT here, because they explained it pretty well. So I am taking the 5 use cases to explain about how the various institutions has transformed this particular the education part of that. The first would be the NC in the United States. This is the 4th largest engineering institution in the US. And these people, what are the game software which is coming there? The top 20 games softwares is being developed by the students of these campuses. And that contributes close to 90 billion of the multimedia industries. The 20% of things is being contributed by these particular set of students. And their contribution to the industry is heavy. Now, how they be able to do the digital transformation? They did it in the 2 ways. One would be on the VDI portion of it. Rather than students would be having a high-end workstation or anything, they created a concept very long time back, bring your own anything. We talked about device. They say BYOA. You bring any devices, and then you operate from anywhere, and then you can do that. So probably something like this. I have an iPad, or I have some Samsung tablet. I want to do an AutoCAD programming from an Android device, which would not be close to impossible. There they can do that. How the architecture will explain it, how the flow would be there at the later slides. So they could be able to give a different experience for the students who want to learn it. So they are contributing a top 20 game softwares at any point of times in the industry. That's what the one part of that. The second would be, they have many use cases in the UMass. One would be interesting case, this campus is pretty big. The pretty big, where they also have the police patrol. The police patrol need to do the inspection of all the particular campuses at various places, and they need to go there and write the incidents. Now what they're doing is they have the very limited number of the human staffs. Whenever any incident happens, they don't go to the police station and write the incidents. They just open the tablet, they do it, and then they'd be recording it, anything that's happening it. And plus, in addition to that, they'd be able to do the more amount of time on the patrolling, rather than go back and do the theory works of that. The second use case, what they'll be doing it is the camera part of that. The campus will be enabled with the large number of the cameras across the various places. Whenever a staff or the supervisors want to monitor it, you don't need to be in the campus. You can be anywhere. From there, you can log into the campus in a very secure way, and then control the cameras, and then focus on anything. You'll be able to capture it. That increases security, safety of the campuses, big time. And in addition to that, they also have the libraries, magazines, and everything will be published. The third use case would be where it's the visionary of the leaders. What they thought about it is in the Malaysia, there are multiple things, multiple islands also, small islands, where there is no proper internet connectivity. Now it's becoming very challenging, the country to give the uniform education across the countries. Only the city people would be able to get the better education. The remote villages or the schools in the islands would not be able to get the better education. Now how this could be transformed? What they did here is, they implemented the VDA technology at the campus, at the headquarters. And initially they started with 1,500 students, where they started initially to try it out how this is be working out. Once it's successful, right now they're having a 25,000 primary schools, means starting the schools to the higher secondaries. They'll be using the VDA technology. So what the government assured it is, all these 25,000 the government schools would get the equal education across the country. The school can be in a city, or the school can be in one of the small island, which will be under the sea, means in the sea, where they cannot be able to have any internet connectivity. They would have a very connected like a BSAT link with a very small bandwidth, where they'd be able to leverage that. So that's a way where the education has been transformed using the VDA. Third would be in our own particular districts, Corunya. In the Corunya, all the things has been virtualized, all the labs. One example would be where they have the main campus in the outside of this particular things, right? The other, the MBA institutions happening in the city. If they want to try it out, they don't need to travel all the way to the main campus. They could do it remotely. So here the software will be completely administered, and then the licensing will be managed, and everything is being taken care of it. And then the other use case would be the IIT Madras, where there are a large number of research has been happening it. The people are creating a large number of patents, and then they'll be doing it. Now, when people want to evaluate it, the internal peoples, okay? The information also not should be leaked before it get published or before the patent has been issued. So they need to distribute the information in a very secure fashion. So if suppose a student or a particular lecturer, because all the professors and everybody is allowed to write many journals, right? The articles, they will be publishing it. What if we want to give it to particular co-professors, evaluate how these particular things are there? So they need to distribute it. Have a portal, publish it, so the internal people will be able to see that, and they give their particular commands, and then they'll be able to modify that. That gives, at the same time, there is no risk of anybody copying it. That way, they'll be able to create the data security using the virtual technology. These are the use cases. What has been some of the use cases, okay, where the campus has been adapted at various places. Certain campus, something like whether you are operating from the lab or operating from this anywhere in the particular campus, or you are driving it, or from home, or from the holiday, or any time, you can be able to access the any labs. That's what the virtual technology will be able to bring into the table on the lab part of that. And there are many benefits. What will be happening to the management and the students in the IT departments? The management in terms of something like the challenges like if there is a new particular curriculum has been happening it, how soon I'd be able to adapt it, and then how soon I'd be able to implement it. That'd be a challenge. And they need to be the best out of the technology, what they need to have it in the particular campus, which needs to be implemented much faster. That is being taken care. In terms of students, they want to learn the new technologies much faster. They need to experiment many things. What are the new software, the new things are there, they should get a time and then the resources to evaluate that. In terms of the IT departments, it could be something like a challenging whenever a new particular academic year starts there. They need to go across all the campuses. Typically, the campus will not be very small. It would be big, correct? So the one particular lab would be there in the civil engineering. There they'll have 10 or 20 desktops would be there. One lab would be there. And mechanical would have similar. And electrical would have multiple labs. But the number of IT staff would be very limited in many campuses. And you need to walk across everywhere. And then you need to do that. And then you need to patch it. When there is a problem, the lab will be starting at 9 o'clock or at 10 o'clock. When a student comes there, he said, this is not working. Then immediately they need to call it. That particular IT staff will say, I'm working in a different department right now. I'll come back later. Then the 2 hours downtime would be there. That particular student will be asked to come the next week or the next day. This is what would be traditionally what would be happening it. Now, when you centralizing it, the data center, and then virtualized it, it would be easily possible for a very limited IT staff sitting at their own place and then modifying any parameters and then deploying the new technology. Suppose a new curriculum is being launched. They are now ready, and the next day itself, they could be able to roll out across the campus. They want to go back to the older curriculum, they can do that. They could be able to get easily. That's the benefit what the IT staff would be able to get it. And typically, we take the 4 different pillars. I'm going to talk about 3 pillars related to the education. One would be how the data centers could be modernized, what's the benefit, and then how the digital workspace could be used, how we can be able to achieve the security part of that. In order to say the data center modernization, let's say for example, nowadays the people would be adapting LMS, learning management systems, and the parent portals where they want to monitor what the particular kids are doing it, what's the particular exams, how they are scoring it, and everything. Okay, or it could be something like the people who creates a particular invention, they want to record it so that the other campus, other sort of people want to see that. Suppose if my particular professors are writing a journal in a year, 3-4 journals are writing it. My set of professors, I need to publish it in my particular website so the people will be able to access it. So their requirements of a good data centers, it not be very bigger. It could be a 2 or 3 servers. Okay, there I need to be able to enable running a multiple applications and then also having a student's own mail service where the students will be able to do that. Or then could be something like an interactive system where the students and the lecturers could be able to do a chatting to talk about it. Say for example, there is one particular program has been initiated and then the people are doing it. And on the subsequent days, the students having a doubts, they want to question it and then where the professors will be able to reply to that. Such things what could be in the data centers, what we can be able to do that. Other area could be the remote students. Now not only the regular students would be doing the evaluation part of it, there are also remote students would be attending the courses and then doing it. How we can be able to give the information to them, how we can be able to publish it. That's what the data centers would be able to help us to do that. And here what is the benefit here is you would be able to do with a very minimal footprint of the servers, you could be able to run a more number of applications. You don't need to have the 10 or 20 servers or 40 servers. You could reduce the number of servers, one, and you don't need to have the multiple locations. You could put everything in a centralized location, and all the department information could be put in a single location. The benefit could be your the power consumption, the real estate space, and then the maintenance, and everything could be drastically reduced. The number of IT staff who want to do that would be minimized. So the benefit would be the multifold. And if you want to do a new sort of an application or new sort of things you want to do that, you can quickly go to the new technology. You want to roll back also, you can do it much faster. This is what the benefits, what you can be able to get it in the education, means the data centers modernizations. The digital workspace is all about how I can be able to give the labs to the students. The labs could be of multiple in nature. One could be a civil, one would be the mechanical. Civil would be requiring these applications, STAD and CAD would be requiring it. Mechanical could be requiring multiple applications. Computer would be requiring different kinds of programming. Some programs could be a cost, some could be free. There could be multiple things would be there. Typically, instead of we having a lab which would be fixed for a particular students, where I would be able to attend the lab only between 9 to 1 in these particular things. Now, what you can have is you can have a common data center on these particular things. You could be creating any labs, could be equivalent to something like running an AutoCAD version 8 and 9 together. You could try it out with the 8 also, you could try it out with the 9 also. Whenever you wanted to have, you could be able to switch it across. Or I want to upgrade to the newer version, you can do it much faster. At the same time, this also would be where you don't need to invest something like a 140 workstation, you need to invest for these sharing across 40 people in a different department. Because not all labs is going to happen simultaneously. You could have a minimal resources through which you would be able to share it to the larger number of audiences. That's what possible. And typically these things would be involving the multiple technologies. The one would be where the virtual desktops. What we do it here is, we take the data center. On the data centers, we'd be implementing the virtualization, and then we load all the applications on an operating system, and then we'll be publishing it very securely to the student. I'll come back to the flow diagrams, how this would be happening it. Then other would be the storage technology. Rather than you having the server separately, and then the fabric and then the storage managing it separately. Okay, you are not an IT institutions to IT companies to manage all these particular bigger infrastructures. So bringing the storage closer to the computing, so that you will be able to manage the storage much efficiently using the vSAN technology. And people are talking about the security aspects, whether creating a new networks. You don't need to depend upon the physical network. Because the physical network would be keep evolving it. Without depending on the physical networks, how you'd be able to isolate it and then do it at the virtualization level, and then increasing the security portion of it. Of course, I'll be discussing in detail in the later slides, where you can bring in all the security and the network attributes to the virtualizations. That can be done in the NSX part of that. Then, once it is done properly, how you'd be able to manage and monitor run very efficiently, using the monitoring part of that. This is what we'd be able to do it with using various solutions. And the other would be the NVIDIA part of that. When you have the very high graphical application, what you need to do it is, you need a high-end workstation, what would be requiring it. High-end workstations with the graphics card and all the expensive applications what you're requiring it. Let's assume a situation where you have a particular lab, mechanical lab, where there is a 40 students, then you need to have the 40 workstation, you need to have it. Similarly, you have a civil institution also, there is a 40 is requiring it. There are 40 desktops with all the graphics card will be requiring it. Similarly for the computer, again a 40 would be requiring it. If the number of department would be increasing, if the number of subjects are increasing it, equally you need to have the more number of desktops. Otherwise, the IT staff would need to be put a heavy pressure, you need to change the image more frequently, which would be close to impossible to managing it. Now what you do it is, you have the common data center. On the common data centers, you would be creating a pool, something like any point of time, 100 students would be able to do any labs. Where 100 students could be either a 20 from a mechanical, 30 from a civil, and a 10 from a electrical, doesn't matter about it. I created a resource which could be able to cater the simultaneous 100 connection. All 100 could be a mechanical, or all 100 could be a computer, anything could be mix and match. That gives a very heavy flexibility. At the same time, the students can bring in their own, they could just bring in on their own laptop, which could be a low end, or could be a tablet, or it could be any devices, the old desktops, what they're having it. They could be able to operate upon that. That not necessarily only from the campus. It could also be from the hostel, or it can also be from the home, if it's been permission has been granted. where they can log in at any point of time and doing it. Typically what we need to have is, suppose if we need running an AutoCAD or a CATIA, I need to have a server, a workstation with an operating system, something like a Windows 10, with an application of a CATIA, and then this licensing. Then I need the graphics card, which I need to do that. To do that, all these things I need to invest, a student need to invest some huge amount of money. Rather than doing it, we have virtualized it. At the central location, you put some common servers, maybe a couple of servers, puts the graphics card centrally, and then you're loading the application, and then you're virtualizing it. Students from anywhere could be able to log in very securely, and then provide their credential. There, that would be checked with your server, whether he is still a student there. Once it's been authenticated, you'll be provided the relevant application. If I'm a civil student of a third year, when I log in, I'll get the civil third year's curriculum would be loaded, where I'd be able to look at, and then I log in, and I can be able to play around. So that changes the way how the students will be able to experience the labs. And then once this is all would be done, how efficiently you will be able to manage the various part of the things. Either you're managing the entire stacks, or you're managing the conventional applications, what you've been newly deploying it, or your legacy application, what you've already adapted it. You could be able to do that. And then also, how will you be able to measure it? How many servers I will be requiring it? You need a mechanism to do that, right? How many servers I need to have it to cater these particular students? That could be exactly measures that can be able to given it. And then also giving the various SLAs part of it. Say for example, there is a committee who has been going to audit it, okay, in terms of the licensing, or from the central university they're coming there and auditing it. How many desktops are having it? What kind of application are having it? They want to do an inventory part of it, anything. You could be able to do it much faster. And this gives you the increasing the efficiency part of the complete data centers. In terms of the usage, in terms of the applications, in terms of lesser investments, getting the best juice out of the hardware, and then your investment part of that. And in terms of the things, how the students will be able to access it to the lab. Either they can be there in the on-prem, either Wi-Fi connected, if it's a Wi-Fi enabled campus, or it could be from the physically connected network from the classrooms. From any devices, they don't need to have the powerful devices. Once they log in, okay, either through a firewall, if it is from the external community, or from the inside campus, means that directly they logs in. Once they logs in, okay, they will be provided the username and password. He provides his username and password. That goes and checks with your directory service. This particular student is a current student or not. Yes, he is a student. Which year he belongs to? A civil third year. A civil third year would be of this particular application, what would be requiring for to doing a lab. So that particular things would be publishing, this is for the lab what would be available. And suppose I be running something like a multiple applications. I'm running an AutoCAD, I do not know the present version, I'm just saying an example. AutoCAD 7 version what I'm running it. Okay, suddenly the professor or HOD says to the IT department, change all the AutoCAD 7 to the 8. Because I taught about the new version which is launched yesterday. Now you don't need to go across, change it everywhere. Okay, just create one more thing using an app volume. AutoCAD 7 has one particular volume. AutoCAD 8 is a different volume. When a student logs off and then logs in back, the AutoCAD 7 would be removed, AutoCAD 8 would be implemented directly within a fraction of seconds. So they could be able to experiment it. Suppose they decided it, okay, roll back from AutoCAD 8 to AutoCAD 7. You just need to log off and then log in back. So AutoCAD 7 would be appearing it and doing that. Or it could be something like he would be running it some older desktops and he want to try it out a new application, or he want to try it out a particular multimedia application, he created it. He want to see how this will be behaving in the IE8 and then IE9 and then IE10 and IE12. You want to see on a different browser how this will be happening it. Is it possible for us to publish all the Internet Explorer version, all the Firefox version on the same system? Not possible, right? Here you can do it, multiple browsers and a multiple version of the application could be published simultaneously, that people will be able to try it out. To see the particular application, what they developed it as a part of their particular curriculum or part of their assignment, check it about various browsers, how this will be behaving it. And making it the simple part of that. Everything will be centrally managed. So the IT staff don't need to be distributed. That is where the horizon architecture part of that. Typically what's happening here is the students coming from the internet, from any client, from any desktops or a tablet or anything, he logs in via a firewall, or locally from the campus he directly logs in, where he supplies username and password. That checks with the credentials of the Active Directory or the directory services, where it will be supplied. Then it will be provided the required amount of a desktops. It could be a Windows 10, or it could be a Linux, or it could be the Windows 7. Even it's possible to do Windows XP also. Of course, the Microsoft doesn't support it. We can even publish the Windows XP also. That they'd be able to do that. And then comes the security part of that. Here, the security part of things is very complex actually, because most of the security technology depends upon agent based. Now the challenge comes. I'm going to give it to the student a desktop or the lab with an admin provision sometimes. If not, there is multiple methods for him to crack the password of the particular things. He goes and uninstall the antivirus. He goes and crack it. He found some tools at $10 at the internet, downloads it, and then crack all my particular security setting because of the agent-based approach. What if you can eliminate the agent-based approach, you put it at the hardware level? Not actually hardware level, I'm just saying it to understanding it. At the hardware level, the security has been implemented. Whatever you do at the software level, you can't do anything at all. How it works here is, I have this server, on that we implemented the hypervisor, then install large number of operating system. Rather than me installing the antiviruses, easy to explain, antiviruses at the OS level. We implement the antivirus at the hypervisor kernel level. So the students will be able to see, once he logs in, he can only see the Windows system. He can maximum reboot the system and then see the BIOS settings. Beyond that, he cannot see anything there. He will check whether the antivirus is loaded in the system. No. He look at the service panel. Is there any of the AV services running? No. Is there any desktop firewall has been running, disabling it? There's nothing. At the same time, they're trying to launch an attack to the public internet site. Maybe download an Nmap tool and trying to launch an attack externally. It is not possible because the security will be implemented at the kernel level. Kernel where you will define it. These particular desktops of the students who belongs to the mechanical engineering would only able to talk to the server assigned for the mechanical engineering student. At the same time, you're trying to attack an administration service. You may not be even able to connect it. Suppose, think about a risk. Rather than doing it, he just goes and then logs in. He's trying to attack it to the Indian government website directly from here, from the application service. He cannot be able to launch it. Probably the course, what you'll be teaching it could be an hacking course as a part of the curriculum. Okay? But still, he cannot be able to initiate the hack attack against any service other than the already assigned targets. So he'll be only able to connect to that. If we try to fiddle around, there is any setting is done at the system level. Is there any IP table is there and then go and then modifying it? Is there any antivirus has been loaded and then go and then disabling it? Then nothing is there. And you do not know how it's happening. It all happens at the kernel level, what will be happening it at the hypervisor, not at the operating system kernels. That's what the security what we bring into the users. So how it helps? You don't need to worry about whether the AV is being updated and then running it there. And is it being disabled? Is the firewall setting has been configured? What if the new VM is created without any agent? You don't need to worry about anything. Students could be able to go and create a new VM also. And you don't need to worry about it. It could be the super administrator, it could be the domain administrator, it could be any administrator. But still, you cannot modify any settings. How this works here is, we have multiple things. One would be the microsegmentations. What we do microsegmentations, typically microsegmentations, we are saying a firewalling it. Firewall will be the generally the agent-based approach. Let's say, for example, most of us are familiar with the Windows or the Linux. If we take a Windows will have the desktop firewall be enabled. If I'm an administrator, I can log in and then I can be able to disable the Windows firewall. Even though the group policy or anything would be able to supply the antivirus settings, if I'm the administrator, I can go and disable the firewall settings. Or let's take a Linux, it could be the IP tables, right? Where the IP tables, what they'll be able to create that. If I be able to log in as a root user, I can go and disable all the IP tables. So there we'll be able to disable security settings. Now we don't do that level. We do at the kernel level. So it sits something equivalent to at the cable of the particular VMs. The policy has been implemented. So nothing there in the particular operating system. So we designed it. These particular desktops, what's assigned to a student, would only able to talk to these particular IPs. It can never able to talk to anything else. So that way the security will be increased a multifold. That's what we call the microsegmentation. Then comes, suppose if you have something called multiple servers are running there, okay, how I can do the load balancing it? Or I want to do the routing features. I just want to teach you something like it involves a multiple routing protocol requiring it. Then I need to go and then enable all my physical servers, physical router and switches where I need to go and then configuring it. Instead of you doing it there, you just go and then do it at the kernel level. You design all the policies there. So just like the mouse click again, you're doing it. Probably all of you would have been experimented about the virtualization. how easy it is to create a VM. It will be simple. If you have the VM of particular image, you can select it, right click and then copy and then paste it, become a new operating system, you have it. That's simple. Similarly in the network, what we can create the same attribute. I have one particular network, I select it, I copy it, and then I'm pasting it, I have a new network, what would be created to me. That's how we can do that. And what way it has been helpful? It is helpful in multiple angles. Sometimes the data criticality may not be higher important in certain cases. That cases, you don't need to worry about the antivirus part of that. The antivirus has been taken care. So the AV operates the kernel level. Or the firewall policing. Or I want an IPS to be enabled. Any of the security features, what we have it, we could be able to enable it without any agent on the operating system. So there the security nature will be improved. Or I want to create a very complex networks without going and then touch my underlying networks. You can do that. So those benefits what you can be able to achieve it using the NSX. And typically what we do it is, even though in the starting we saw the pillars, what we saw that the empowering, the modernizing data centers, the digital workspace, transform the security. And then also we are putting it to the integrating the public clouds. Suppose if you want to take a one part of the workload to the public cloud, we can be able to take it up. Here what we do it is using the virtualization, the compute virtualization using the vSphere, where you can be able to virtualize more number of servers could be drastically reduced to the very less number of servers. Suppose there are 10 servers, we can bring it to something like a 1 or 2 servers. Even 20 could be make it to 1 or 2 servers. That way reduce. Rather than me having the multiple storage appliances, we can bring in the storage attached to the locally connected hard drive on the servers. You don't need to have the separate storage is not required. On the network side of it, you don't need to have the load balancer or any of the higher end routing would not be requiring it. You can bring in all the features within the particular the kernel level, including the firewall, antivirus and everything. So thereby the network could be virtualized. Once it's virtualized, it's all would be software controlled. It's easy, right? If you have one particular server, if you want to have a different server, you can't put it in the server in a Xerox machine, take another copy in the things. It's not possible. This is a physical attribute. In a particular software format, you have one particular file. It could be a VM, or it could be a network, or it could be a load balancer. You control C the particular load balancer, you put a control B, you have different load balancers available. So what it means is, theoretically speaking, rather than me investing one load balancer, I could have a 10 load balancer. Rather than one firewall, I could have 10 firewalls. You can be able to multiple it. It's so simple. That's what the software defined would help us. Because software defined, you could be able to operate upon on the cloud also. You can take it from here or you can take it to anywhere in the networks. Once you have that, you could be able to publish any applications. It could be the traditional application, it could be the cloud native application, it could be the modern application like a containers or a Kubernetes or a MES-OS or any of the containers applications. Okay, then you can be able to access it from any devices, from anywhere. So this is what we be able to bring in there. Then this helps us to do the, from anywhere they can be able to bring in their own devices and then it can be able to run the show. And what are the benefits what you'll be getting it? End of the day, it all comes to the cost. I'm an institution. How would I be able to shell out a large amount of money to bring in there? But at the same time, it brings in the new kind of an economy. What if we, rather than running the particular course in the on-prem, okay, I could also be able to run a more of a distance education programs. So the students will be able to learn my particular, the mechanical, the new particular kind of a technology, they can learn it remotely. So they can be able to have the new kinds of revenues could be possible. So there are multiple ways how this particular cost could be easily justified. And we are the leader in these particular things in any reviews. Be it Gartner or Forrester or IDC in any of the technology what we are having there, we are the leader. And we want the most of the virtualization market in ourselves either on the compute or on the network or on the storage. And we have a large number of logos on various things. These are some of the samples who we have in our particular things part of that, who all adapted the digital transformation in the campus.